Here are the solutions to homework set number 13 for ECE 111. This homework, we're looking at solving circuits with diodes. Now, diodes are nonlinear elements. That's one of the challenges when you get to electronics. You're looking at nonlinear elements like diodes, transistors, MOSFETs. The VI characteristic for diode looks like this. This is the voltage across the diode. Here's the current. What that does is when I have a circuit with diodes, I have n equations and unknowns, just like before. Conservation of current still applies, conservation of voltage still applies. However, when we write the equations, we'll have n equations that are nonlinear to solve. That's where MATLAB comes into play. With fminsearch, I can solve nonlinear equations. So for example, the first problem is here's a circuit, here's the VI characteristics for diode, and VD is voltage anode to cathode, ID is the current anode to cathode. Write the equations. So here I've got four unknowns, V1, V2, ID1, ID2. First two equations are the diode equations. The voltage across diode 1 is V0 minus V1. That's the voltage anode to cathode. The voltage across diode 2 is V1 minus V2. So that's two equations. The next equation is V0 equals 10, if you want to count that one. At V1, the current left plus the current right plus the current down must equal 0. The current left is minus ID1. The current right is plus ID2. And the current down is V1 over 200. There's my fourth equation. Fifth equation is at node 2. Current left plus current down equals 0. That's minus ID2 plus V2 over 300. V2 over 300 equals 0. 5 equations, 5 unknowns. Now to solve, that's where MATLAB comes into play. I'll create a function in MATLAB. I called it diode2. I'm going to pass matrix Z. Parsing it, what Z means is that's the voltage. That's your V1, V2, and V0 is 10. Once I know the voltages, I can find the currents through the diodes. Those are the diode equations. I can then write the node equations. So minus ID1 minus ID2 plus V1 over 200 should equal 0. Plus ID2. Got a mistake here. There it is. Plus ID2 plus V1 over 200 equals 0. Minus ID2 plus V2 over 300 equals 0. If I guessed correctly, the currents will balance. If they're incorrect, I'll have a current imbalance, return the sum squared error, and then let MATLAB try to minimize the sum squared error. To call it, I can sit there and say, let's call function diode2. Are the voltages 5 volts, 4 volts? And it says, these are my voltages. This is your V0, V1, V2. Here's the current imbalance. It's not 0. So guess again. Here I'll let MATLAB guess for me. That's what fminsearch does. It's going to guess again, until the currents balance. So here's the sum squared error in current. And then get the voltages. So that is problem 2, solving in MATLAB. In Circuit Lab, I can build a circuit, find the voltages as well, and note that I get pretty much the same answer. So this is MATLAB solution, Circuit Lab solution, basically the same. If you're taking Electronics 1, you'll then have a third solution. Go into lab, build a circuit, and measure the voltages. They'll be close, a little bit off, because all models are slightly inaccurate, but it'll be close. And that's solving a circuit with 2 diodes. Problem 4 says repeat in a more complicated circuit. I now have 3 diodes. Solve for V1, V2, V3. The procedure is the same. For diode 1, the voltage anode to cathode is V2 minus V1, gives you this equation. Diode 2, voltage anode to cathode is 0 minus V2. Diode 3, anode to cathode is V3 minus 0. So those are your 3 diode equations. Now write the node equation. At V1, the current left, which is V1 minus 10 over 100, plus the current down, minus ID1, plus this current, V1 minus V2 over 200, plus this current, V1 minus V3 over 300, plus this current, V1 minus 0 over 400. All that has to add to 0. So there's the next equation. At diode 2, let's do that in a different color. At diode 2, the current up, current left, current right, current down equals 0. The current up is plus ID1 minus ID2 plus V2 minus V3 over 50 plus V2 minus V1 over 200 equals 0. And the third equation is at node 3, current up, V3 minus V2 over 50 plus ID3 plus V3 minus V1 over 300 equals 0. So that gives me 6 equations for 6 unknowns. To solve, again, I'll use MATLAB. I'll create a function called diode3. I pass it z, parsing it. That means the voltages V1, V2, V3. Once I know the voltages, I know the current through the diodes. Then I can write the 3 node equations. The current should all balance equal 0. If I guess incorrectly, they don't balance. Return the sum squared error, and guess the voltages until j equals 0. I'll do that. Well, I can sit there and guess. Are the voltages 3, 2, 1? And it says, nope, wrong. Let MATLAB guess for you. So I'm going to use fmin search, minimize this function. There's my initial guess. It iterates a while and eventually winds up at 5.33 volts, 1.7 volts, 0.79. Here's the sum squared error, basically 0. So that is the solution. I can check the answer in CircuitLab, build the circuit, find the voltages, and CircuitLab does exactly what we just did. It iterates, finds the voltages until the currents balance. And if you notice, the MATLAB solution, the CircuitLab solution aren't exactly the same. Again, CircuitLab uses a slightly different model. All models are slightly inaccurate. They're close, and that's typical what you see in electronics. The solutions are close. If I go into lab and build the circuit, again, I'll have a different answer, a third answer, that'll be close. But again, that just says all models are slightly inaccurate. So that's homework set number 13. In electronics, the challenge in electronics is we start introducing nonlinear devices. So we're trying to solve n equations for n unknowns that are nonlinear. With MATLAB, I can do that. So that's homework set number 13 for ECE 111.